This is a Data General Nova 1210, and sitting on top of it is a teletype Model 43. And this is a really interesting configuration because the Data General Nova is absolutely a mini computer. But you can see sitting here, this is very much so desktop sized. And that's because the 1210 only has a 4-slot backplane. Currently we have a CPU, 16K core memory, 8K core memory, and serial card slotted into it. But by having only a 4-slot backplane, they were able to make the power supply much smaller, resulting in this desktop-sized mini computer. And in the previous episode, we got this, I believe, fully operational. And the Model 43 sitting on top of it is also fully operational. Unfortunately, these two currently don't talk to each other, because the serial card that's in the 1210 is currently wired up for 1200 baud. But the Model 43 is only capable of 300 baud. Also, we don't have any mass storage going on here at all. The Model 43 is just simple user I/O. So what gives? Well, there's one more piece to this puzzle, and that's this thing right here. This is a Techtran Industries cassette tape drive for this machine. It came with it, and it's supposed to be used with it. However, this kind of raises more questions than it answers. It's important to note that as far as we know, this is a ran when parked configuration, so it should all plug into each other in some way and just work. But that slot saver I/O card that's in there has 2 ports on it, but both are wired up for 1200 baud. And this Techtran Industries tape deck does actually communicate over serial, and there's a little selector knob on the back that's currently set to 1200. So that makes perfect sense, except our Model 43 can still only do 300 baud. Also, if we look at the little piece of paper that's taped to the front of the tape deck here, this is the bootstrap loader for an older Model 33 type teletype that would have a paper tape punch and reader on it. That, I think, is a clue as to how this machine was originally configured. I think we're looking at an upgrade here. This machine was originally built by a company called EDAX International, and they build spectrometers. So this would have been the primary control computer for an EDAX 707A. And when EDAX built this machine, I don't think they had this Model 43 and this Techtran tape drive on it at all, because I got 2 extra cards with the machine. One is an 8K core memory, which would have meant that total they had 16K of core, and the other is a current loop card. I also got a couple other manuals for a Model 33 automatic send and receive teletype. At which point, this bootstrap loader actually makes perfect sense. So my thinking is that at some point in time, they decommissioned the Model 33 teletype, upgraded to 24K of RAM, put in an RS-232 serial card, and then this Model 43 teletype now plugs into this tape deck at 300 baud, and then that whole combination communicates with the 1210 at 1200 baud. Because that combination is going to present itself as a really fast ASR33 to the 1210. So everybody can use the same bootstrap loaders, the same programs, the same everything that they've been trained on without having to make any changes. And we actually have a tape for this tape drive that has some of the programs that they would have been running on this. It has the binary loader, which I think is necessary to load any binary files. Then we have 7EP, patch, burp, and frame with STDs. I don't really know what most of those do, except for 7EP and burp. Those are in this manual, and they are specific programs to dealing with an EDAX 707A. But we do have a bit of a problem in that this tape is old, and I tried to get an audio recording of it just as a backup, and I started getting a pretty gnarly squeal out of it. And I knew that wasn't good, and I really don't want to destroy this because this may be the last known surviving copies of this EDAX software. So I had to pull the tape out, take a second, and think about what the next correct step was. And well, that correct step has been on my t-shirt the entire time. AJ at Forgotten Machines is an absolute legend, knows more about data archival and tape restoration than anybody I have ever met, and is just a very dear friend. I am always looking for an excuse to have a chat with AJ because he's just such a lovely person. So let's give him a quick ring and see if he can help us get past this tape squealing issue that we're having. AJ, thank you so much for taking my call.
I'm honored, man. It's always great to talk to you.
So I was messing around with the Data General Nova, and we have a tape drive for it. And I tried to get a audio recording of it with just like a regular audio player, and I started getting a squealing noise out of it about a minute in. So what was that squealing noise that I was hearing?
That is something that's called sticky shed syndrome. And that is where the binder that holds the layers of the tape together, and over the years, the binder absorbs moisture, and that moisture makes it sticky. And so it was sticking to the head as the tape was moving over the head and causing friction. And that friction had resonance, and that resonance was the squeal.
If I continued to run it like that, that would destroy the tape, correct?
Well, it certainly wouldn't do it any good. I mean, when I've done that in a period of time with data tapes, after a while, the tape literally adheres to the head and sticks solidly to the head, and it doesn't move anymore. So yes, you'll very potentially damage the tape.
Okay, so where do we go from here? Like, how do we fix this? How do I get it so that I can get the data off of that tape safely?
All right, so the most well-known, well-documented way to solve sticky shed syndrome is to bake the tape for a period of time at a very, very specific temperature under very controlled conditions. And what that does, it causes the moisture to evaporate, and then it becomes less sticky. But it only lasts for a period of time, maybe a few days, maybe a few weeks, before it becomes sticky again. So it's only a temporary solution.
Okay, and so when you say bake the tape, am I just going to put it on a baking sheet and throw it in the oven?
Absolutely not. And here's why. According to experts that know far more than me and have far more experience, the optimum temperature for baking tapes is about 58 degrees Celsius or 136, 137 degrees Fahrenheit. And your regular residential kitchen oven cannot, and it is not designed to heat at that low a temperature and regulate at that low a temperature. So instead, I recommend a device called a dehydrator, which is designed to heat in that range. And so it's actually, in my opinion, kind of the perfect device to use for that, because they don't cost that much. They're designed to do exactly what we're doing with them, and they operate at those temperatures. And then, in order to make sure you're operating at the right temperature, I would recommend that you get some of those inexpensive thermometers that are designed to take the temperature for HVAC maintenance. Harbor Freight has them for a couple of bucks, and I like to use a couple of them. Actually put a hole in the side of my dehydrator so that I could see exactly above and below the tape where the temperature is. And I should point out that I actually created a page on one of my websites called QICreader.com that shows you exactly the procedure that I've used for baking data tapes. Again, I'm not an expert with this, and I give credit to a lot of other people on this webpage of mine, like Al Casso and Chuck Guzes, and a bunch of other guys who've done this stuff with other data tapes in the years past, and they got this advice from other audio tape heads who have done this procedure for decades, because this has been a known issue with tape, with magnetic tape of all kinds.
Well, and you're my expert, so I'm going to follow your advice, get my hands on a dehydrator, and we're going to bake that tape. So, AJ, thank you so much.
All right, good luck with that. I can't wait to see it.
All right, let's bake that tape. I got my hands on a Kosori food dehydrator for cheap online. And I'll be using Mrs. Usagi's external thermometer to confirm temps. It's a pretty simple setup, all things considered. I'll just go ahead and pop the tape in place, then kick the power on and get the temperature set to 136 Fahrenheit. Then hit go and it'll just sit here and run for the next 8 hours. It slowly ramps the temperature up, which is great because we don't want to temperature shock the tape. And you can see we're slowly climbing above 40 degrees Celsius here. And finally it gets up to a touch over 57 degrees C, which I think will work just fine. So while that bakes, let's get to work on the tape drive itself. I do like how it has this little cable management piece on the back, but we need to get this thing all the way apart. After unwinding the cables, a lot more is visible on the backside here. As you can see, this is a Techtran Model 8410, and we really only have two options on the backside: a DUP on or off switch and a baud rate selector switch. We also have a DB25 plug for plugging the terminal in, and then a captive cable that goes to another DB25 plug for the modem or CPU. I'm not entirely sure how to get this thing apart, so I'm going to just start taking out as many screws as I can until the thing just falls apart. And after taking out way more than I needed to, the top pulls right off. The cooling fan is connected with little spade connectors, which makes it an absolute breeze to remove. Then there are 3 cards in total, and all 3 are held in place with these little brackets on the top. After removing the brackets, I can just pull all 3 cards straight up and out. Now that we have this thing apart, let's take a bit of a look at the inside here, starting with the tape deck. And first of all, it's absolutely beautiful, but also I don't need to worry about belts or anything like that because it's direct drive. There are 2 12-volt DC motors directly acting on the tape. Below that, we have the 3 card edge connectors that are going to take the 3 cards that I pulled out. We have some power transistors along the side over here, another one over here, and a giant heatsink. And then we have our big power transformer here. But there's so much more going on this piece that is not visible because it's all underneath this aluminum case right here. It's a little precarious, but I was able to kind of crack it open and take a look at the underside. There's a ton of point-to-point wiring going on. Our big smoothing caps, there's 3 of them. We can here, and here. Those are all stuffed up underneath here. What an absolute nightmare if you ever have to service this thing, but it is nice and compact. And actually these caps I think are gonna be totally fine. They look just pristine, no signs of leakage. They might have even been replaced at some point in time. And there's a ton more going on under here, but hopefully I'm not gonna have to mess with any of that. There are 3 boards in total, and this one is the serial interface board because we've got this big COM 2017 chip over here. But there are some other interesting ICs on here. These socketed ones right along here are AM3341s. These are first in, first out 64x4 memory chips. And then we have some 74199s over here. And these are 8-bit shift registers. So this is not just the serial interface card, this is also the memory. So if the computer is sending data faster than the teletype can print it out, that data is going to be stored in these memory ICs here. Up next is this board that sits in the middle, and I actually have no clue what this board does. It's all 7400 series logic chip. My guess is that this is building up the state machine that is the tape drive. So whenever you tell it to seek or look for blocks or anything like that, this is the logic that controls all of that. And finally, we have this board, and this is the board that the tape drive itself plugs into through these 2 red plugs right up here at the top. And there's a whole lot of analog circuitry going on here due to the analog nature of a tape deck. Half of it is unpopulated, and that's because I believe they sell a version of this tape drive that has 2 cassettes on it. And so this would be the same board, just populated with the rest of the chips. We can see it looks like there's a bunch of op amps and all sorts of analog wizardry going on right through here. All in all, I'm hoping that these boards are pretty much just functional, but there is one problem that is going to need to be addressed, and that's with these tiny little wet tantalum capacitors here. I actually had no idea what kind of capacitors these were. Avery identified them for me, so thank you, Avery. But it looks like a lot of these are spewing their guts out the backside. They are 20 microfarad at 25 volts, and I've got a bunch of electrolytics that are 22 microfarad at 25 volts. So I think that'll be all right. I'm gonna go ahead and swap those in though, because these are not healthy. My replacement capacitors aren't axial though, so I'm going to need to get a little creative here. I'll bend the positive lead, which is the longer of the 2, around 180 degrees. Then I'll slip a little bit of heat shrink tubing over the top of the cap to both insulate and physically locate the lead in the right spot. And Mrs. Usagi upgraded hair dryers years ago, so I've been using her old dryer as a heat gun, and it works like absolute gangbusters. Once I've prepped all the replacement caps, I need to remove the old ones from the boards. I'll bust out my desoldering iron, and after removing as much solder as I can, I'll clip onto the cap lead with some hemostats and work it right out. And just look at how gross these things are. They definitely would have caused some problems. Now that the old caps are out, let's get the new ones in. I bent the leads to match the spacing of the through holes, then slotted the caps into place and soldered them in. And there we go. All nasty caps have been removed and fresh new goodness is in place. There were 8 caps in total that got replaced, 6 on the tape control board and 1 each on the logic board and serial board. All right, first proper power up and who knows how many years. Hopefully it works. We'll just give it a shot here. We got a light in the front. None of the buttons seem to do anything. But we do have a little light coming out of the front here. That is an excellent start. It means we're generating some electricity. All right, well, we'll keep troubleshooting this, figuring out what's going on. As you can see, things have gone a little bit pear-shaped. I figured out that I could rewind and then do nothing else. So I figured it's time to check to see if we've got any ripple on the power rails. And without schematics, I'm really just kind of taking random shots in the dark here. But these big capacitors are going to be big smoothing caps for presumably 3 different rails here. So I've got the scope in AC coupling mode here. We're at about 500 millivolts per division. So I'll go ahead and flip the power switch on. And you can see that whatever rail this one is just dead solid. There's absolutely nothing going on. So let's check this one. And we got a little bit of ripple on this one, but that's about 100 millivolts. Let me change the scale a bit here. So we got 100 to minus 100 millivolts, so about 200 millivolts of ripple. Not great, but actually not that terrible. So let's go down to this rail on the bottom here. It's gonna be you. That is a lot of ripple. That's about plus 1¼ volt to minus 1¼ volt. That is too much ripple. That's gonna be causing a problem. And I don't think the capacitor is the problem here because I snipped one leg and I've got this Keysight LCR meter hooked up to it. And you can see it's coming up at 5.1 millifarads. It's a 4700 microfarad capacitor, so it's reading at 5100 microfarads. That's really pretty close. If I press and hold this, we go to ESR. And ESR is 0.03 ohms. I think this is a good capacitor. That 4700 microfarad capacitor comes into an LM323, which is this guy right here on the big heatsink. This is a 5-volt voltage regulator, so we're sending 12 volts into that. And if I turn the power on here, we can see on the scope, we've got our nasty amount of ripple on the input. However, if I move the scope over here to the output and we check it again, that's like a dead solid 5 volts. So maybe just the way that an LM323 works is that it's going to cause that kind of ripple, but either way, what the PCBs are seeing is a clean 5 volts. But while I was doing this, the tape deck started trying to behave. Some things are working, some things are definitely not working, but it's in an interesting state. The power light does not come on, but clearly I have power. This switch doesn't seem to do anything, and if I read the manual, it says that should blink if a certain signal is available, and then if I flip it on, it should go solid steady. But because it never actually blinks, I think that means that that signal is not showing up correctly, even though I'm pretty sure that I'm sending that actual signal. There's some interesting things happening here. You can see on the laptop here, I've got 2 terminal screens hooked up. One of them, this one on the right, is hooked up to the modem CPU port, and this one on the left is hooked up into the terminal port. And if I type on this one, you can see it's looping back. I'm not doing that. As a matter of fact, if I flip the switch on the back, it no longer loops back. And then I can flip that switch up again, and we're looping back again. So clearly some serial communication is working here, but also if I look through the manual, it has a list of special character codes that I can send that tell the thing to do something. Like I can start a read, start a write, stop a read, stop a write, rewind, partial rewind, or search. So let's try starting a read by typing Control Q, and nothing is clearly happening here. But if I switch this switch up to ASCII and I hit Control Q, now it actually starts a read. Look at that. So this ASCII binary switch here, which again I think is the edit switch, is actually doing something. It's preventing the terminal from sending control codes, which is actually I think exactly what it's supposed to do. Now I can also do something like Control R, which is start a write. That does come on. So let's send it, actually let's do an Alt V here and send it just a bunch of text. And while I'm sending it this text, yeah, there we go. Look at that. So you can see once I send it enough text, it actually writes that text down onto the tape, or at least it's trying to. So we finished sending our data. If I do a Control T, this should stop write, and it did. It looked like it wrote some final trailer stuff going on there. Now let's rewind it, and I can rewind it by doing a Control Z. And here's a problem. It doesn't know that it's finished rewinding, and I can't exit out of that. That's probably a little sensor problem on there. If I just power cycle it, that brings it back up to a normal state. Now let's try to read this back. And if I look at the manual here, read was Control Q. So if I hit Control Q here, it is actually reading, but I don't know where it's sending that data, or if it is actually sending data out. We could still be completely broken in other ways. All right, the old girl's making me work for it today. You can see that there's this single line here that's connected here, 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 and here. And this is just connected to ground. So you can see that if I push my probe up against that, there we go. I have the other side of my multimeter connected up to ground. Now here we've got ground coming into the center, and if I check the top pin here, which has the yellow wire on it, you can see we're showing 0.5 ohms, and then if I flip the switch, that goes to nothing. So that's how our switches are working. Now if I check this switch down here, which is the online switch, the one that we haven't gotten any life out of, if I check the bottom pin, no matter what position the switch is in, we never get a connection, which is maybe an indication that my switch is no good. But I think I might be able to jumper over to the other side here, because this should be an identical switch, and that might be able to get this switch working and bring the system online. All right, behavior has changed somewhat. It's currently offline. The bulb should be flashing and it's not, and I don't know if that's because something is broken or because the bulb itself is bad, but we're in ASCII, and if I look at the COM5 window here, I am looping back. So I can type hello, that is coming in through the terminal port and looping back. I can also control it from here by doing like a Control Q, which starts a read. I can do a Control S, which stops the read. And that's all working pretty much exactly like how it was before. So let's now change this to online. And let's go over to COM port 3 here. Now, if I send it a control character like Control Q, it continues reading, which is fantastic news, although we're still not getting any output, which is not good. But that Control Q character came via the CPU cable, and it means that we came online, because if I go offline and I hit Control Q, nothing happens. But if I go online again, hit Control Q one more time, we read. I did figure out one final thing that might be a clue as to what is broken here. Whenever we're in online, anything that the CPU sends into the system should be echoed on the terminal. And that pass-through is actually happening, but it's happening wrong. So on the screen here, COM3 on the left is the CPU, COM5 on the right is the terminal. And if I type, say, the letter A, I get an exclamation point. But I don't get an exclamation point every time. This time I got an A, then I got an apostrophe, and I get a couple of capital A's in there, and then an @ symbol, and a couple of spaces. Something is very, very strange here. This goes for every single key. If I try to type the quick brown fox jumps over the lazy dog, you can see it's sometimes right, sometimes very wrong. Dog came out correctly. So we're able to communicate with the system. We're able to send it serial data, but something is happening somewhere. It's losing it. Maybe we have a flaky RAM chip. Maybe we've got some other more sinister thing going on. And anytime I tell it to read, if I hit the button here and tell it to read, none of that data makes it back out to here. It never puts out whatever it wrote back down. I tried to see if there was some rhyme or reason to the erroneous data that was passing through this system there. And of course, there's a pattern. There's always a pattern when it comes to RS-232. And the pattern in this case is there's never a 1-bit set when there shouldn't be, but there are sometimes 0-bit set when there should be a 1-bit instead. So I think what's happening is the memory in this thing is shift register based. So as the buffer fills up and that shift register is looping around, we're dropping bits in the middle there, but they're always dropping to a 0 and never accidentally flipping up to a 1. But what about the other problem that we're having? It seems that we can send data into this thing. It tries to write it down on the tape, but every time we tell it to read, we never get data back out of it. And oh, it's so close. We're so close to functional. Now, unfortunately, I don't have any schematics for it. So I've been kind of taking stabs in the dark here, hoping to stumble across the problem, but I think at this point it's going to require a more methodical approach. So what about the tape? We put the tape in the food dehydrator and let it bake, and after about 30 hours, I pulled it out and tried to get a read of it. And it was good for about 2 minutes, and then after about 2 minutes, I started getting a faint hint of a squeal. So I stopped all of that and I put it back in the food dehydrator, and I'm probably gonna let it bake for another 30 minutes. So we are gonna come right back onto this project soon. I think I'm gonna have to order some parts just in case, but we have to come back to this soon because I need this and the Nova and the Model 43 to all be up and running before VCF Southwest, which is coming up very soon. It's like 8 weeks away. So we're gonna be right back on this as soon as I get my hands on some new parts and we reverse engineer enough to figure out how to properly do troubleshooting on it. So I wanna thank you all so much for watching, and I hope to see you in the next episode.